Okay, let's have a look at the Engaa 2019, Section 1, Part B, the advanced maths questions. First question on advanced maths. We have find the area of the shape bounded by these four lines. So we need to consider how these appear on a graph. So y equals 0, x equals 0, coordinate axes, and x equals -6, vertical line through -6, and then we've got sloping line which we can sketch easily. We can rearrange to find the intercept. Intercept is 2, so the shape we're interested in is bounded by those four lines, so we recognize that as a trapezium. So we've got two parallel sides, length 5 and length 2. Where do we get the 5 from? Well, if we substitute x is -6 into the top equation, then the intercept is at y equals 5. So we've got base is 5, top is 2. So we add the lengths of the parallel sides, multiply by half, and the height is just from 0 to -6, so that height is +6. Work it out and we get 21. Okay, next. This one we've got a cubic. Told we have a curve, cubic equation, and we've got an unknown coefficient for x squared, unknown coefficient for x, and an unknown constant at the end. But we're told that there's local maximum when x is -1 and local minimum when x is 3. But we've got to find out what the value of p is. So this is clearly about differentiation. So we're going to differentiate what's given, see where that takes us. So that loses for us the r. We've got p and q left in here. The derivative, local maximum and local minimum, should be 0. So we know that this should work. We should have factors for this quadratic like that. Actually, we're going to put a 3 in front for factorizing the derivative in order to get 3x squared. So we expand that, we get 3x squared minus 6x minus 9, and we need to compare that with the general case above, and the number in front of x tells us that p has to be -3. Next. Right, we've got to find out the value of b in a plus b root 2, being a simplified form for 1 over the cube of 1 minus root 2. Okay, so that's standard method for rationalizing the denominator. Multiply top and bottom by 1 plus root 2. So a difference of 2 squares on the bottom gives us 1 minus root 2 within the cube. So we've got -1 on the denominator. You can cube a -1 and get a minus. So we've got minus outside. 1 plus root 2 cubed. And then we can work out the cube of that. Well, we can do 1 plus root 2 times the square of 1 plus root 2. So that's that expansion we've got there. And then multiply that spare bracket into the second one. And we can see the number in front of root 2 is going to be -5. Next. So we've got to solve this trig equation. We're told that x is acute. What are the possible values of tan x? Okay, so how are we going to do this? Well, dividing by divide everything by cos, we lose cos in the first term, we've got tan times sine over cos. Well, that's just another tan, so it's tan squared equals 5 over cos, and 1 over cos is sec. So this is A2A level coming in, and there is a relationship between tan and sec through the Pythagorean identity. 1 plus tan squared equals sec squared. Okay, well, we don't have sec squared here, so we need to square both sides in order to get that to work for us. So we square the left, so we're going to get tan to the 4 there. Let's not worry about that too much. On the other side, we're going to get 25 sec squared, and we'll replace sec squared by 1 plus tan squared. So that's why we've got this here on the right hand side. 25 times 1 plus 25 times tan squared x. So this is now all tan. We can collect to one side, and we get the biquadratic. So we've got tan to the 4 minus 11 tan squared plus 24 is 0. So we can factorize that in tan squared, as this is a quadratic in tan squared. And so this is what we get. Factorizing, product of minus 8 and minus 3 is positive 24. The sum is minus 11. So that works out. So tan squared is either 8 or 3. And we square root to get plus or minus root 8, which is simplifying to 2 root 2, plus or minus root 3. But we need to pick x so that tan x, so that x is acute, and when x is acute, tan is positive. So we're just going to have root 3 and 2 root 2. So that's the answer. Next. Okay, circle question. So we've got an equilateral triangle, side 8, vertices are on the circumference inside of a circle. What do we know so far? Well, we've got 8, we can drop a perpendicular to get 4 to bisect the base. We know all the angles 60 for an equilateral triangle. And we've got 4 root 3 must be the height, because we've got the adjacent, so we can use tan 60, and we need to know that tan 60 is root 3. Okay, and that's how we're going to get 4 root 3 for the height. Right, what else does it say? What's the total of the 3 areas shaded? So the 3 areas shaded, that's the difference between the area in the circle and the area of the triangle. So the area of the triangle is easy, it's a half the base times the height. So that's going to be 4 times 4 root 3. So 16 root 3, so that's the triangle. Right, now a little trick is going to be to realize that the centroid for the triangle will coincide with the center of the circle. So that's going to be around here, and the idea is that we need to use that is at 2/3 the distance from the vertex to the base. So 2/3 of 4 root 3 will be the distance from the vertex to that point, which is also the center of the circle. And so that's going to give us the radius. So that's 8 over 3 root 3, and so the area of the circle would be pi r squared. So we use the radius that we've got with pi r squared to work out that area. Then all we have to do is take away the area of the triangle from before, and that agrees with answer E. Next. Which one of the following is the real solution of this equation? Okay, well, this is a classic kind of disguised quadratic in 5 to the x. 5 to the 2x is 5 to the x squared. Now we don't have 5 to the 2x, we have 5 to the 2x plus 1, so we need to take out a factor of 5 to get rid of that plus 1. So we take out a factor of 5, so it's 3 times 5 in front. That leaves 5 to the 2x. If you like, we can change 5 to the x to y, so you've got y squared, 15y squared minus y minus 2 is 0. Okay, that factorizes, no problem. I'm going to have to split 5 and 3 at the front, and that means that y is 2/5 or minus 1/3, and so we can use log base 5 on that, and the log of a negative is not a real number, so we need the first one, and that coincides with answer B. Next. Okay, this is quite extended, this one. So what we've got here is we've got a function, don't know what it is, don't need to know what it is, but we're told that the integral of 2 times the function between minus 1 and 2 plus the integral of the same function between 2 and 4 is 4. And also we're told the integral from minus 2 to 2 of 5 times the function, take away the integral from minus 2 to 4 of the function is equal to 7. And these make two simultaneous equations, not the usual that you were used to, but here's the thing, that you've got to work out the integral of that function from 2 to 4. Well, we can see that features already here, so it's really going to be about solving for that. So let's see what we've got. So equation number 1, we can rearrange that just to get the thing that we want, being the subject. And equation number 2, we're just going to rearrange that to get the integral from minus 2 to plus 2 working for us, because that's on the right hand side in this changed equation 1. So if we just look at that, we're going to add this integral from minus 2 to 4 onto the other side, and then here's the important part, which is here the limits are from minus 2 to 4, and we're going to split that up. We're going to split that up to be minus 2 to 2 and then 2 to 4. So split that integral into 2 integrals, and that includes the one that we're after, and it includes the other one that appears in the first equation. Okay, so rearranging that, we can collect onto the left integral from minus 2 to 2, so instead of 5 lots there's 4 lots. 4 lots of the integral from minus 2 to 2, and that's equal to 7 plus the integral from 2 to 4. Call that equation 3. So this is where we can combine equation 3 and 2. Sorry, 3 and 1. So we're going to double equation 1, and we're going to use equation 3, so that we can eliminate this integral minus 2 to 2. And then we have an expression which has, an equation which has only the integral from 2 to 4 in it. And then it's a matter of making that the subject. So when we make that the subject, we get the required answer, which is 1/3. Okay, so quite a few steps in there, but when we see one like this, it's going to be about separating the limits to get what we want and then dealing with what's left. Okay, next. 35. Okay, so we've got the integral from 0 to x of function of t. What's the coefficient of x to 4 in the expansion of f of x? Well, clearly it's got something to do with binomial expansion. So what we can do is just do that t integral. So that's just straightforward chain rule. Add 1 to the power, divide by the power, divide by the derivative of the inside. Between 0 to x, we can work that out. We're only interested in the coefficient of x to the 4, so we're not going to worry about the 0 too much. What we're going to have to do is to look at the expansion of 3 plus 2x to the 8. Okay, so it would be too much of a chore to work out all the powers in expansion up to 4, so we really need to use the term, the general term in the binomial expansion. We've got the 1/16 there from this integration. So what do we put in this general form? Well, the power is 8, n is 8. R, well that's the power of b, or x that we're after, which is going to be 4. And the first term is 3, and the second term is 2. I don't need to put 2x because we're after the coefficient, so there's no need to clutter it up with x's. So I can work those out, put that in, and the NCR, the 8C4, well, going to have to work pretty quickly with Pascal's triangle to get that out, but it's quicker if you remember the factorial definition of NCR, and we get quite a bit of cancellation, which makes it easy to work out. So if you follow those steps, you're going to get 70, and we can put that in, and then simplifying, we're going to get 70 times 81. So just going to do 70 times 80 plus 70, so that's 5600 plus 70, and that's the required answer. Next. Okay, we've got 3 internal angles in a triangle, alpha, beta, theta. Got 2 equations here, simultaneous equations. Okay, you can make life simpler by calling tan alpha t and sine beta s. So just have to solve these equations. Basic method from GCSE days. And we get down to t is 1, so you have to know that tan alpha equals 1 means that alpha is 45 degrees. And then sub that back in, and you're going to get sine beta as a half, and you've got to know that means beta is 30 degrees. And the sum of these 2 angles, take off 180, you get theta, and that's the required answer of 105. Okay, 39. This is the last advanced maths question in section 1, part B. So we need to find the complete set of values of x for which this cubic is positive. Okay, it'd be really nice to factorize that, although it's not completely obvious what to do. We can game the system a little bit if we have a look at the answers. 4 is in most of the answers, and we've got 4 at the end. So trying 4 is a good bet. So you can use x minus 4 as a factor. Either you divide it into the cubic, or more quickly factorize by inspection, and you get this factorization. Or if you were doing division, you'd get that quadratic factor, which is just a perfect square, x plus 1 squared. So x plus 1 squared, that's always 0 or greater. And so the only thing we need to think about is what this factor is going to do. So in order to make the cubic positive, that factor has to be positive, so x has to be greater than 4. And that concludes solutions for the Advanced Maths in Section 1 Part B for 2019 Engaa.